Hello everyone, welcome to Guild Institute of Gemology. I am Instructor Wu. Today, I will introduce how to use this Gemological instrument kit. This is a kit launched by Guild, a highly portable and practical toolkit for daily gem identification. First, let's introduce how to use gem tweezers. Tweezers are used to securely hold gemstones. They allow 360-degree observation of a gemstone from all angles. They can also be used together with other gemological instruments. Step 1. First, clean the gemstone. Lay the gem cloth flat on the table and begin cleaning. Step 2. Place the table facet of the gemstone face down on the gem cloth. The table is the largest facet on the top of the gemstone. Step 3. Hold the middle section of the tweezers with your thumb and index finger. Align the tweezers with the gemstone. Use the notch at the tip of the tweezers to grip the outer girdle of the gemstone. Apply moderate pressure while gripping to avoid launching the gemstone accidentally. Then observe the gemstone under a light source from all angles. During observation, you may rest your elbows on the table. This improves stability and reduces hand fatigue. This is a 10 times loop. It is used to magnify the internal and external characteristics of gemstones. It allows for more detailed gemstone observation. This helps evaluate gemstone quality. First, unfold the lens. Place your index finger through the center of the loop to support it. Keep the lens close to your finger, but do not block the lens opening. This helps maintain stability. It prevents the loop from shaking during observation. Step 2. Hold the gemstone with tweezers. Position the tweezers between your middle finger and ring finger. Keep approximately 1 finger width distance between the gemstone and the loop. Hold the loop close to your eye, about 1 finger width away. Slightly adjust the distance between your eye, the loop, and the gemstone, until the viewing field becomes clear. Then observe the gemstone from all angles. Keep both eyes open during observation. For larger objects, such as bangles, you may hold them directly with your other hand for observation. When observing, also pay attention to maintaining approximately 1 finger width distance between the bangle and the loop. Keep both eyes open throughout the observation. This is a flashlight. It is a full-spectrum light source. During use, it can provide illumination for a spectroscope and color filter. This is our ultraviolet fluorescence lamp. It uses 365 nanometers ultraviolet light. It is used to observe fluorescence and phosphorescence in gemstones. This helps distinguish different gem varieties. Some gemstones emit visible light after exposure to ultraviolet light. This phenomenon produces visible luminescence. If the visible light disappears immediately after removing the UV source, this phenomenon is called fluorescence. If the gemstone continues glowing after the UV source is removed, the continued emission of light is called phosphorescence. For example, both red spinel and red garnet are red gemstones. Red spinel usually shows fluorescence, while red garnet usually shows no fluorescence. We can quickly distinguish them using a UV fluorescence lamp. Place the gemstone against a black background. Cup your hands tightly around the gemstone. Try to keep the gemstone in a dark environment. Avoid interference from surrounding light. Then shine the UV flashlight directly onto the gemstone. Observe the luminescent reaction inside the gemstone. This is a dark field illumination attachment. It is mainly used to simulate dark field illumination under a microscope. The light passes upward through the gemstone from below. This helps reveal internal characteristics of the gemstone. Turn on the flashlight and align it with the bottom of the dark field attachment. Place the gemstone on the center stage platform. Observe the gemstone's internal features from above. It can be used together with a 10 times loop for more detailed observation of internal features. This is a dichroscope. It is mainly used to observe pleochroism in gemstones. It helps distinguish isotropic and anisotropic gemstones. Pleochroism refers to the phenomenon where a gemstone displays different colors from different directions. When light passing through a gemstone does not split, such gemstones are called isotropic gemstones. They do not show pleochroism. Examples include diamond, garnet, and spinel. When light splits as it passes through a gemstone, Such gemstones are called anisotropic gemstones. These include ruby, sapphire, tourmaline, aquamarine, and others. They exhibit pleochroism. Using this small instrument, we can quickly distinguish between these two categories of gemstones. For example, both emerald and tsavorite are green gemstones, yet they can be distinguished effectively. Emerald is an anisotropic gemstone and displays pleochroism. Tsavorite, however, is an isotropic gemstone and does not display pleochroism. First, hold the gemstone with tweezers and align it with the light source. Hold the dichroscope in the other hand. Aim the hexagonal end of the dichroscope toward the gemstone. Keep it as close to the gemstone as possible. Ensure the light source, gemstone, and dichroscope are aligned in a straight line. Look through the round eyepiece. Carefully observe the color differences in the two viewing windows. Rotate the gemstone 360 degrees during observation. If color differences appear between the two windows in a certain direction, rotate the dichroscope 180 degrees. If the colors in the two windows switch after rotation, it confirms the gemstone is pleochroic. However, please note that a dichroscope is only suitable for colored and transparent gemstones. Opaque or lightly colored gemstones may not show obvious pleochroism through a dichroscope. This is a polariscope. It is mainly used to distinguish isotropic and anisotropic gemstones. It can also be used to distinguish gemstones from jade materials. It is also used to determine the pleochroism of gemstones. First, turn on the flashlight. Aim it at the bottom of the polariscope. By rotating the silver knob on the side, secure the flashlight in place. Then place the glass stage in the center of the polariscope. Next, rotate the upper polarizer of the polariscope until the viewing field reaches complete darkness. Then place the cleaned gemstone onto the glass stage in the center. Rotate the stage 360 degrees. Observe the changes in light and dark through the viewing field above. This is aquamarine. It is an anisotropic gemstone. During the 360-degree rotation, it will show 4 alternating light and dark positions. This is isotropic spinel. As you can see, during the 360-degree rotation, the viewing field remains almost completely dark. This is polycrystalline jade, specifically quartzite jade. We can observe that, during the 360-degree rotation, the viewing field remains almost completely bright. The polariscope can also be used to observe pleochroism in gemstones. Rotate the upper polarizer of the polariscope until the viewing field reaches maximum brightness. Clean the gemstone. Place the gemstone on the center stage of the polariscope. Rotate the stage 360 degrees. Observe the color changes of the gemstone through the viewing field above. If the gemstone shows obvious color changes, it indicates pleochroism. Please note that the polariscope is only suitable for transparent or translucent gemstones. If the gemstone is opaque or contains a large number of fractures and inclusions, the observation results may be affected. This is a Chelsea filter. It can assist in determining the origin of emeralds. It can also be used to distinguish cobalt-colored blue spinel from ordinary blue spinel. It can also distinguish ordinary green tourmaline from chromium-bearing green tourmaline. First, place the gemstone against a white background. Then turn on the flashlight. Direct the light source toward the gemstone. Hold the Chelsea filter close to your eye. Keep the filter approximately 30 to 40 centimeters away from the gemstone. Observe whether the gemstone changes color through the filter. The application range of the Chelsea filter is relatively limited. It is mainly suitable for certain blue or green gemstones. For example, Colombian emeralds usually appear red under the Chelsea filter, whereas most emeralds from Zambia and Brazil do not turn red. This allows for a quick indication of emerald origin. For another example, high-value cobalt blue spinels and chromium-bearing green tourmalines will appear red under the Chelsea filter, while ordinary iron-colored blue spinels and common green tourmalines will not appear red. One important point to note is that the Chelsea filter should only be used as an auxiliary testing tool. Even Colombian emeralds may sometimes not appear red, and emeralds from Zambia or Brazil may occasionally appear red as well. This is a spectroscope. It is used to observe the absorption spectrum of gemstones. When chromophore elements are present in a gemstone, they absorb certain wavelengths of visible light, thereby producing various gemstone colors. The spectroscope is mainly used to observe gemstones with characteristic absorption spectra. First, place the flashlight vertically on the table. Turn on the flashlight. Place the gemstone directly above the center of the flashlight. Then pick up the spectroscope. Use the flat end of the spectroscope and point it toward the gemstone. Please note that it should be held very close to the gemstone. Then cup your hand around the light source to avoid interference from ambient light. Next, align your eye with the pointed end of the spectroscope. Observe the internal optical effects through the eyepiece. At this point, the gemstone, spectroscope, and eye should all be aligned in a straight line. Through the eyepiece of the spectroscope, observe the gemstone's spectral characteristics. Mainly identify the black absorption lines, or absorption bands within the field of view. Then compare them with the characteristic absorption spectra of common gemstones to determine whether the gemstone displays a typical spectral pattern. This is our gem scoop. It is used for the safe and efficient transfer of gemstones. It also helps during the transfer process to avoid contaminating the gemstones. It can also be used for batch sorting and gemstone management. During use, it can be used together with tweezers for picking up and transferring gemstones. Place multiple gemstones on a gem cloth. Several gemstones can be transferred at one time. Avoid direct hand contact during operation to reduce fingerprint contamination. Secondly, it helps protect the gemstones because the smooth metal edges will not scratch the polished surfaces of gemstones. It also helps prevent rolling and accidental damage, suitable for diamonds, rubies, sapphires, emeralds, and more.